Okay, today we're going to wrap up chapter 13, our first trig unit of the year, with inverse trig functions. And we're going to use inverse trig functions to find angle measures. We've pretty much been solving for side lengths, finding ratios of side lengths, finding various trig function values. But today we're actually going to find angles. So inverse trig functions to find angle measures today. Okay. Inverse trig functions are used to find angle values. And in other words, sine of theta equals 1/2. Well, what is theta? Okay. How do we find it? Well, we use what we call the sine inverse, inverse sine, or arc sines. They all mean the same thing. They're written in two ways. Well, we can write it as sine to the -1 or arc sine. And this goes for cosine, tangent, any of them. It'd be tangent to the -1, cosine to the -1, arc tangent, arc cosine. So in order to do this and solve this, what we would do in solving this equation is we would apply the arc side to both sides. And so we would find what theta is. Arc sine of theta, or what angle, when we take the sine of it, gives us 1/2 ratio. If you look at your unit circle, well, that's 30 degrees. I'm going to show you how to do it on the calculator here in a little bit as well. Okay, but that's really what we're doing for. We're doing arc sine, arc cosine, arc tangents today. You can use special triangles or calculator. There's a button on our calculator, like I said. So stay tuned. Evaluate the expression in radians and degrees. Okay, no calculator, use special triangles or unit circle values. Well, I'm going to show you both. I know I say that. I'm going to try to do it without a calculator, and then I'll show you how to do it with a calculator. So, inverse tangent of square root of 3 over 3. So, what triangle has square root of 3 in it? Is it a 45, 45, 90, or is it a 30, 60, 90? Well, let's draw them both out and let's compare. So 45, 45, 90 is a 1, 1, square root of 2. I don't see a square root of 3 on that one. How about 30, 30, 60, 90? 30, 60, 90 degree triangle. Well, 1, 2, square root of 3. I see a square root of 3 there. So tangent is opposite over adjacent. Opposite over adjacent. Well, I don't see square root of 3 over 3 here, but maybe I see the flip of it. If I look at the tangent of 30, that's 1 over the square root of 3. And if I were to simplify that, I'd multiply by the square root of 3 over 3 and get square root of 3 over 3. So in this case, that's 30 degrees. In radians, we can multiply that 30 times pi over 180, and that would reduce to pi over 6. So that's pi over 6 radians. You can also look at the unit circle. On the unit circle, remember, 30 degrees up here, well, that's pi over 6 in radians, right? So there's another use of the unit circle. Obviously, tangent's not directly on there. Sine of square root, inverse sine square root of 3 over 2. Well, square root of 3 over 2. I see square root of 3 and a 2 directly on the unit circle. Sine is opposite over hypotenuse. Well, to make a square root of 3 is the opposite, it has to be across from 60. 2 is hypotenuse. So this is really 60 degrees. 60 times pi over 180. Well, that equals pi over 3 radians. Go to our unit circle. That's 60 degrees. Pi over 3. And remember, sine is the y coordinate. It's right on our unit circle. So sine or cosine values, they're pretty easy. Inverse cosine of 3. Inverse cosine of 3, well, let's look here. I don't see 3 on any of these values. In fact, you can't take the inverse cosine of anything less than -1 or greater than +1. So this is no solution. Okay? This is no solution. If we did this just to show you on our calculator, if I wanted to do these on the calculator, I have to go to mode and make sure I'm in degree. I know it says radians or degrees. It's not going to give you in terms of pi if you do the radian measure. So you're always better off when you're solving for an angle to solve for it in terms of degrees. But let's say I want to do the first one, the arctan or inverse tangent of the square root, second x squared, square root of 3 divided by 3, 30 degrees. So I can do any of these on the graphing calculator. Inverse sine of the square root of 3 over 2. Okay, and in fact, some of these we're going to have to because they're not going to be on our unit circle. And if I try doing the cosine, arc sine of 3, watch what happens. Error, error, error. Okay, it won't work. So we can do these on our calculator if we want to as well. So the first type of problem they're going to have you solve is they're going to ask you to solve for an angle. They're going to give you a sine, cosine, or tangent, and then they're going to give you a quadrant. And the way they're going to give you quadrants, they're saying where theta is between 270 or 360. And they could do this in radians as well. Just the radians can determine what quadrant we're in. Use the unit circle. But if we're between 270 and 360, if you look at the unit circle, this is 270 to 360. We're in quadrant 4. In quadrant 4, all students take calculus. Students take calculus. Cosine is positive. So we know that we're going to get a positive, or it's a positive ratio that works here as well. Now we're dealing with the angle measure. So we'll see where this comes into play with this here in a minute. Okay, but we are in quadrant 4. And that's going to, what we get in the calculator may not match up exactly, or by reduce special triangles, may not match up exactly with what we get in our calculator. And I'll show you how to do that in a minute. So, first things first, we have to isolate theta. We do that by taking inverse cosine of both sides. And theta is the arc cosine and inverse cosine of 2 over 5. I don't know if any special triangle has a 5 in it or 2 in it, so I'm just going to go to my calculator. I'm going to do the arc cosine of 2 over 5. And I get 66.42. Well, we know that 66.4, say, that would be somewhere in quadrant 1. I don't want to be in quadrant 1. I want to be in quadrant 4. So what are we going to do? Well, we're going to use 66.4 degrees as a reference angle in quad 4. So in quad 4, a reference angle equals 360 minus our angle, right? So we can solve this and work in reverse to figure out what our actual angle will be in quadrant 4. If our reference angle is 66.4 degrees, I'm just going to plug it in, and now I'm going to solve for theta. Subtract 360. When I subtract 360 from both sides, I get negative 293.6 degrees. Well, it's the opposite of our angle, so if we divide by negative 1, we get 293.6 degrees. So theta equals 293.6. Make sure you check that out. Go to your calculator. Do the cosine of 293.6. And we should get something close to 2/5. 0.4003, right? You're like, how's that close to 2/5? I don't know, Mr. Coon. If I have math fraction, that's not going to work, but if I hit 2 divided by 5, that's 0.4. I would say that 0.4 is pretty close to 0.4003. Okay, remember we rounded this value to 66.4. So it's going to throw everything off a little bit. So it checks. This is our answer. Okay, now we're going to go back to our right triangles and we're just going to solve for missing angle. This is probably where you might see this on an ACT type problem. You probably find these even easier than the last one because we're not having to go all over the coordinate plane. We're just basically in quadrant 1. You have to be if we're in a right triangle. All the angles have to be less, all the non-right angles have to be less than 90. So it wants us to find theta. So we're standing down here. Here's theta. We're in this corner. So 5 and 13 are the labeled sides. We could use the Pythagorean theorem to find the other missing side if we wanted to, but we probably don't need to. We have an opposite and we have a hypotenuse. What trig function uses opposite or hypotenuse? Well, the trig function uses opposite and hypotenuse is sine. The one that has a button in our calculator. So sine of theta equals 5 over 13. So how do we solve for this? We take the arc sine or inverse sine of both sides. That cancels out. So in our calculator, we type in arc sine of 5 over 13. Arc sine of 5 over 13. Oops. Let's put a hit second delete. It actually lets you insert stuff. So let's insert a division key right there. And we get 22.6 degrees. So theta is 22.6. We'll say 62 degrees. Always check it. Okay? In your calculator. How would I check that? Well, see what the ratio of 5 over 13 is as a decimal. Then go sine of that answer, 22.62. Get the same thing. Now, if you rounded it to 22, we just did sine of 22.6 or 62. You're going to see that you're off a little bit, but it's pretty close, right? So that's what should happen. When you plug it back in, both ratios should be the same. Find theta. Well, let's look at this one. We're standing up in this corner now. This is an adjacent. This is an hypotenuse. The trig function uses adjacent and hypotenuse as cosine. So cosine of theta equals 4 over 9. So we do arc sine, cosine of both sides. And we're going to get theta equals the arc cosine of 4/9. Second, cosine 4 divided by 9. And we get 63.6 degrees. What did I say? 63.6 degrees. We always want to check it. So let's plug it in. Let's see the cosine of 63.6 degrees. Does that equal the ratio of 4 divided by 9? It does. It checks. That's the fast, easy way of checking it. Okay, they should be equal or equals. Okay, so we'll do some more practice in class tomorrow with solving these. We only did one example of each, but we will do some more in class tomorrow. So hopefully you feel like we hit this target rather well. We'll practice more tomorrow. We'll see you in class. Have a good day.